Welcome back to part 2 of 8th grade geometry standard number 3, or 8G3. Our learning target is I can describe the effect of translations, rotations, and reflections. And this video is specifically talking about reflections. The same vocabulary as before. Our main focus here is looking at what happens to our coordinates when we do a reflection. So how does our x coordinate change? How does our y coordinate change? Now, in order to do a reflection, we need two pieces of information. The first thing that we need is the same thing that we needed in the first part when we did a translation. We need a pre-image. We need a shape that we are going to reflect. And so I have a triangle here that I've called LGQ, and the location for those 3 points are listed right here. That is my pre-image. Once I do a reflection, I'm going to be at my image. So the second thing that I need is a line of reflection. I need to know, what am I reflecting this line across, or what am I flipping this figure over? A line of reflection could be a vertical line, like this. It could be a horizontal line. It could be a slanted line. And the way that you perform a reflection was described in the video for 8G1. You figure out how many units you are from that line, and you go that same amount on the other side. So for this part, I'm going to ask us to do a reflection over either the x-axis or the y-axis. Those are two pretty common reflections that you might be asked to do. So let's go ahead and do a reflection over the y-axis. I'm going to go ahead and mark that y-axis right here. And we will start by performing the reflection. I'll go with G first. I can do these points in any order. I'm going to count how far G is from my line of reflection. 1, 2, 3 units to the line. That means I need to keep going. 1, 2, 3 units on the other side. Here is my new G prime. I'm going to then do the same thing for point L. Point L is only 1 unit from my line of reflection, so I'll only go 1 unit on the other side. And here's the new location for L prime. And for point Q, 1, 2, 3, 4 units to my line of reflection. I'm going to keep going. 1, 2, 3, 4 units on the other side. Here is the location of Q prime. Now this is looking a little bit messy, so I'm going to clean this up so that we can start taking a look at how things have changed. So while I am erasing, I want you to start maybe figuring out what are these new coordinates? What are the coordinates of L prime, G prime, Q prime? Oops, that's a little bit too large there in my eraser. I'm also going to fill in what my new shape looks like. It looks like my old shape. It is congruent. It is the same size and the same shape as my original object, as my pre-image. The only difference is that it has reflected or flipped over this line. What was that line again? This vertical axis? Oh yeah, that's the y-axis. So this is a reflection over the y-axis. Let's go ahead and jot down what our new points locations are. I'll start with L here, the origin, and -1, 1, 2. So L is at -1, 2. While I'm writing, I want you to be thinking, looking at L compared to L prime, how has this changed? All right, let's go over to point G prime. -1, -2, -3, 1, 2, 3, 4. negative 3, comma 4. Taking a look at G compared to G prime, I want you to start thinking about what has happened here. And Q prime, negative 1, 2, 3, 4, comma negative 1. Negative 4, comma negative 1. I'm going to grab my highlighter here so that we can start looking at the x coordinates to see if they have changed. My original x coordinates were 1, 3, 4. And now my coordinates are negative 1, negative 3, and negative 4. So did our x coordinates change? Yeah, absolutely. They are not the same as they were before. They kind of the same. But what looks like has happened is that 1 became negative 1, and 3 became negative 3, and 4 became negative 4. It's going to be really tempting here to say, hey, these became negative. And while that's true, I'm going to ask us to use a different word here. I'm going to ask us to use the word opposite. The danger in saying that they became negative is that for some students, they might think that no matter what, when I'm doing a reflection, that the values I end up with will need to be negative. Instead, if we use the word opposite when we're describing what is happening to our coordinates, we've got a much better shot at doing the reflections of the coordinates correctly. So what has happened to our x value? It has become the opposite of what it was before. Now, I just said, let's not use the word negative, and then I drew a negative symbol. Well, negative means opposite. Opposite means negative. What is the opposite of 5? Negative 5. What's the opposite of negative 5? 5. So I want us to use the word opposite when we are describing what's happening. And then the way that we show that in our notation is right here, using that negative symbol to say the opposite of x. A little bit confusing. It'll get clearer the more that we practice. I'm going to grab my highlighter again so that we can take a look at the y values to see how they have changed. So my y values were 2, 4, and negative 1. And now they are 2, 4, and negative 1. So did my y values change? No, this time my y values did not change. They're exactly the same as they were. So when I go to write my coordinate notation, this y value is going to stay the exact same. Nothing happened. 2, still 2. 4, still 4. Negative 1, still negative 1. Here's what it looks like in coordinate notation. X, comma, y becomes the opposite of x. Whatever your x values were, they will become the opposite. And the y values do not change. I'm going to reveal that written a little bit neater so you can make sure that you get it down in your notes correctly while we discuss why this happened. So my shape moved in what direction? Did it move horizontally or did it move vertically? Yeah, it moved horizontally. And which letter controls horizontal movement, X or Y? Take a look at the graph because there's a hint. Yeah, horizontal movement is controlled by the X coordinate. So because my shape has moved in a horizontal direction, that's why the X changed. So why didn't the Y change? Well, Y controls vertical movement, up-down movement. Did my pre-image move up at all? No. Did my pre-image move down at all? No. That's why the Y value has not changed. It has remained the same. So when we reflect over the x-axis, this is what will always happen to our coordinates. The opposite of x and the y stays the same. So to do a reflection over the x-axis, you're going to follow those same steps. I've even got my same pre-image here with the same coordinates as before. The only difference is that this time we are going to be reflecting over the x-axis. I'm going to make my line a little bit thinner than I did for that last one. Maybe it will make it a little bit easier, especially because this one is a little bit more challenging. Because our shape is crossing over our line of reflection. So what that means, when I count how far L is from the line of reflection, my new L is going to end up underneath. My new G is going to end up underneath, but look at my new Q. Q is actually going to end up above the line. So it's a little bit trickier. Same process though. So I will start with L, moving 1, 2 units to my line of reflection. So I continue 1, 2 units to mark L prime. G is 1, 2, 3, 4 units from the line of reflection. So I'll continue 1, 2, 3, 4 more units to mark G prime. And X, or excuse me, not X, Q is only 1 unit away from the line of reflection. It's still going to be 1 unit away from the line of reflection, Q prime. So while I grab my eraser and start to clean up these lines, try to make it a little bit easier for us to see what's going on, start thinking about the location of our new points. Where are they? What has happened to their x coordinate and their y coordinate? I am going to go ahead and mark the shape of my new triangle. It is the same size and the same shape as my original. It's congruent. My pre-image and image are the same shape and size. It has not gotten larger or smaller. And now I'm going to go ahead and take a look at these coordinates. Let's start with L prime, which is 1, negative 2. 1, negative 2. Take a look at L, take a look at L prime. How is it changing? Maybe try and figure out what is underneath this box here for how the coordinates are changing. Let's go ahead and take a look at G prime. G prime is 1, 2, 3, negative 1, negative 2, negative 3, negative 4. 3, negative 4. Think about how G has changed to become G prime. And Q, 1, 2, 3, 4, 1. 4, 1, comparing Q to Q prime while I grab my highlighter. You might already have an idea of how these have changed. Let's do what we've been doing. Let's take a look at the x values first. My x values were 1, 3, and 4. Now they are 1, 3, and 4. So did my x values change? Not this time. X values did not change. They have stayed identical to what they were before the reflection. Let's take a look at our y values. 2 became negative 2. Those are, what's the word I'm asking us to use? I'll write it down in a minute. Let's think about it. 4 became negative 4. 4 and negative 4, how are those related? And negative 1 became 1. What is that word? I asked us not to use the word negative. Opposite. All of the y values have become the opposite of what they were. 2 became negative 2. 4 became negative 4. What did negative 1 become? It became 1. They are opposites. Now, of course, I'm going to go over here and I'm going to write a big old negative symbol, and you're going to think, hey, you just said don't say negative. Right. They are opposites. Really important to remember it that way, and this right here is the reason why. A lot of times, if we're using the word negative, A student might make the mistake of seeing this as -1 and writing the new coordinate also with a -1. So I really want us to know what this negative symbol, yes, it is a negative symbol. What does this negative symbol mean? It means opposite. Right here, that is the exact reason why -1 opposite is 1, or a -1 is a +1. However it makes more sense to you. But I do want us to understand really what is happening. We're doing the opposite of what we had before. So how do we write this in coordinate notation? What did my x and y become? Well, nothing happened to the x. It stayed exactly the same. And what happened to my y? Well, my y became the opposite of what it was before. So if you haven't already made a guess at what is behind this box, I'd like you to go ahead and pause the video, make a guess of what's behind there right now. And there it is. Our xy becomes x comma -y. And really quickly, let's talk about why that happened. Here's my pre-image. Here's my image. How did it move? It moved in a vertical direction. It moved in an up-down direction. And which letter controls up-down movement? The Y does. That is why our Y has changed. This shape has moved in a vertical direction. Did my shape move to the left at all? Nope. Did my shape move to the right at all? Nope. There was no horizontal movement. That's why the X has remained the same. Now, we will talk more about doing reflections over other lines because, again, remember, we can reflect over any line, not just the x-axis or the y-axis. We can reflect over any vertical, horizontal, or slanted line, and we will discuss that more in class.